Hey there. In this lesson, in this AAF lesson, we're going to be applying the 5 fun facts of inverses, which you learned in the last video lesson and had some time to do together in class the last time we met, our last live session. So by applying the 5 fun facts of inverses and my knowledge of domain, so notice that's not going away, it's super important to us, I will be able to modify any function to be one-to-one, to be a one-to-one function. So if you recall, one-to-one means that not only does every input have only one output, but every output has one input, right? So that was, and we talked about the vertical line test, means that something is a function. We talked about the horizontal line test, at least a little, means that its inverse is a function, right? So that is what we want to check. So one of the big examples that I came up with, or that I did in the last video lesson, was we looked at a parabola, right? And a parabola, a quadratic, is a function. However, its inverse is not a function. It is not a one-to-one function. So we want to look at how we can modify a function, like what can I do to this parabola in order to force it to be one-to-one, right? So that's what we're going to be looking at in this lesson. So if you remember the 5 fun facts, we had number 1, a function and its inverse are reflections of one another over the line y equals x. That was a big one when we're graphing. We had inverses. We switch the x and y coordinate, right? And then we can solve, and that's how we algebraically find it. Or if you're looking at coordinate points on a graph, to get this reflection, you're switching them. And remember, we reflected a little bit. Oh, get it? Some stuff that we learned in geometry, and you start with the point x, y, and it becomes the point y, x for that reflection. We talked about inverses of a function will also be a function if and only if the original function is one-to-one, right? So if the starting function of the function you're given is not a one-to-one function, we automatically know that its inverse is actually not a function. We talked about notation and the importance of this. So if the original function is one-to-one, right? So that means that its inverse is a function. Therefore, we can use this notation to indicate inverse, right? And this notation's only going to be used if we're talking about a function and an inverse function. Otherwise, you would use y inverse, right? So it doesn't mean it doesn't have an inverse. Its inverse is just not a function. So notation. And then finally, when you compose inverses, you get x, meaning f of g of x equals g of f of x equals x. It's like you do something and then you undo it. So in this lesson, we're going to focus in on this, right? The inverse of a function will also be a function if and only if the original function is one-to-one. So what do we do if it's not one-to-one? That's the big question here. So our goal, so we're going to be given a function f of x. We're going to find the equation of the inverse function, f inverse of x. If it is not one-to-one, we want to restrict the initial domain. We want to modify the domain of the original function to ensure that the inverse is a function. So we want to force it to be one-to-one. So hopefully you've got some paper and pencil, or you've got this PowerPoint printed out, or something to write on so that you can pause the video at a variety of different points and do some of this stuff with me. So think. Where does f of x fail the horizontal line test? So if you have a function that fails the horizontal line test, meaning it is not one-to-one, you want to think about, well, where exactly did it fail it? Where, the question, where is an x value, right? Where is x? So you're looking at where across the domain, right? We're going to restrict the domain, or we're going to change the domain of the function. If it was all real numbers, we want to know, can we limit it to force it to not be, or to force it to be one-to-one, sorry. So when I'm saying where indicates x values. What is the x value where it fails? We are going to, this is an interesting terminology, but we're going to amputate the domain, right? Like cut off the domain to force f of x to be one-to-one, amputate it. Finally, we're going to determine the range of that new function, right? Because, if my coordinates switch, determine the equation of the inverse and its domain, right? How are we going from this step to this step? If the variables switch, right? If x, y becomes yx, that means the domain of this one becomes the range of this one. The range of this one becomes the domain of this one. Oops. Right? So that is why it's important for us to identify the range of the amputated function. Like we're going to change it. We're going to change the domain and we're going to see what the resulting range is because that resulting range is going to be our domain of the inverse. A little confusing, I know. If you're asked to graph the original, if asked, you're going to graph the original and the inverse. Right? They are reflections over the line y equals x. All right. So let's do our first example, right? So how do you know when to amputate, right? So let's watch this one. So we've got this function, f of x equals x squared plus 1. And we want to restrict the domain so that the inverse will also be a function. So here it is. What's the domain of the original? All real numbers. What's the range? Y is greater than or equal to 1, or maybe you're saying 1 to infinity. Okay. Is that 1 to 1? No, look, horizontal line test, right? If I picked the value 4, no, that's not a good one, 5, that actually has 2 outputs, right? If I pick the y value of 5, I'm sorry, it has 2 inputs. That could have been 2 or negative 2. So this is not 1 to 1. Right? So we're going to have to modify this a little bit. It's not a 1 to 1 function. So we're going to cut off half of the graph, right? This is where it starts to fail it. If I'm going from left to right, this x value at 0 is where it starts to fail. It's where it starts to go back up and repeat y values. That's where our issue is. So I'm going to cut off half the function. See ya. And then we're going to graph the inverse. So I'm going to take, there's the line of reflection. I'm going to take, I don't know, 3 points. And we can reflect them, right? So I can stick a point here. We can stick a point, what was this? 1, 2, 1, 2, 3, 4. No, it must have been 2, 5. So it's me 1, 2, 3, 4, 5, 2. I'm like approximating here. This must be 3. 3 squared is 9, 10. So this is gonna be like 10, 3. I don't know. I'm approximating. This is not my prettiest of graphs. And oh, there's a square root function. Right, but we had to restrict the domain. That's not a very good graph. I apologize. What is the domain of the inverse? This one that I just graphed, the domain, you're going to have x is going to be greater than or equal to 1. And your range is going to be y is greater than or equal to 0. Right? I restricted this. When I changed the domain, when it said to restrict the domain, I changed the domain to be x is greater than or equal to 0. So if I gave you a function, I said f of x equals x squared plus 1, x is greater than or equal to 0, this is 1 to 1 because I'm telling you I only want this domain. So do you have to amputate it that way? Did I have to cut off the left side? No, I didn't, right? Unless I specify and I tell you how to amputate it or I tell you how to restrict the domain, it does not matter how you restrict it. I could go back and I could give you one that said f of x equals x squared plus 1 or x is less than or equal to 0. That's totally allowed, right? Maybe I wanted to cut off the other side. And I'm going to cut off the right side with this domain. And then I'm going to end up with a slightly different function, right? I'm going to end up with one that is, it's going to go like this. It's going to be like the bottom half of the parabola down here. Still reflecting over that line, y equals x though. Right? And for something like this, at the end of it, I end up with f inverse. I never even wrote the equation, did I? It's okay. I'll go back. Oh my gosh, I'm a mess right now. Right? I'm going to end up with f inverse of x equals to, well, I only cared about where it was less than or equal to 0, so it's going to be the negative square root of x minus 1. Right? And my domain of that is going to be x is greater than or equal to 1. And my range, well, it's going to be y is less than or equal to, I wrote as 1, 0, right? Or negative infinity to 0, Or I could say 1 to infinity. So unless it says which side you need to amputate, you can do either one. You can do anything unless it specifies that this is what you need to do. If I wanted to go back, so notice this one was the negative part because I cared about the left side. It's the bottom half, so it's negative, right? I want the negative square root. This one, I want the top half. So this is, or the right is where it's positive. You want f inverse of x equals the positive square root of x minus 1. If you put these together, I would get like that full parabola on the side. So if I had just asked you for what's the inverse of this, its inverse is not a function. It's actually plus or minus the square root of x minus 1. And you could only use y inverse there. You couldn't say f inverse of x because the inverse is not a function. So it's a little confusing, but interesting idea. We're going to do 2 more examples. All right. So example number 1 here. I just have the whole thing written up because I thought this might be a great time if you had a desire to, I don't know, pause the video and try it on your own. Maybe, just maybe. Okay, so f of x equals x plus 2 quantity squared plus 1. We're going to graph it and it's inverse on the same axis. So I'm going to put in a few values. I picked this one to start because that's the vertex, right? So -2, 1. I'll plot that point. And I'll do this one. Let's do a few more. Let's do, having some pen issues. If you plugged in -3, what would you get? -3 plus 2, you're going to get an output of 2. I'll plug in -4, I'm going to get 5. If I plugged in -1, I'm going to get 2. If I plug in, oh, no, not 2. If I plugged in 0, I'm going to get 5. -1, 2, right? It's that reflection. So here's my original. Whoa, sorry. All right, so is the original 1-to-1? No, it's not. It does not pass the horizontal line test. Well, what's the domain and range of the original? Well, the domain is going to be -infinity to infinity, or all real numbers, and the range is going to be that y is greater than or equal to 1. So is the inverse a function? No. We immediately know that no, it's not. Right? So, but I do know that the domain of the original, of the inverse is going to be that x is greater than or equal to 1 and y, and the range is going to be -infinity to infinity. Right? If I were to just graph the inverse right now, I had -2, 1, so I'm going to have 1, -2. I had -1, 2, so I'm going to have 2, -1. I also had -3, 2, so I'm going to have 2, -3. Right, so I'm going to end up, what was this? 0, 5, 5, 0. Right, I'm going to end up with this, which is not a function. Right, if you were just asked to find the direct inverse of this, it's y inverse, not a function, plus or minus the square root of x minus 1 minus 2. Right, so if I was going to find the inverse of this, you would probably switch x and y. I was going to solve it algebraically. Subtract 1, x minus 1 equals y plus 2 squared. When you go to take the square root in this step, I was the first person that wrote that. It was not already there. Therefore, it is plus or minus the square root of x minus 1. I want the positive, the plus, and the minus, right? Equals y plus 2. And then finally, I would have to subtract 2. And that's where I would get this. Or maybe you're writing the -2 in front. That's a 1. right? So let's say I told you to amputate this, and I wanted you to force this to be a function. I wanted you to force it to be a one-to-one function. What are different ways that you could amputate the original one, right? I could have said f of x equals x plus 2 squared plus 1, and told you the domain was x is greater than or equal to negative 2. Right? That's okay. That would be me just telling you to graph just this half. That would be just this part right here, which would mean I would result in just this part right here. So then I could say, well, now f inverse of x would have a, what is this? It would be just the positive part, right? It would be the square root of x minus 1 minus 2. And that domain would be x is greater than or equal to 1. And this would change the range, right? The range would no longer be all real numbers. The range would be that y is greater than or equal to negative 2. Right? The other thing you could have done, this was option 1. Option 2 is, let's say I just wanted to do it where I just wanted this half. Maybe we'd say f of x equals x plus 2 squared plus 1, where x is less than or equal to negative 2. Because I didn't say which side to amputate. Therefore, the inverse would be negative, because then I would only care about the bottom half, right? So I want the negative piece of it. The negative square root, because I want the domain, I want the range to be y is less than or equal to 2. So it would be negative square root of x minus 1 minus 2. All right, so just thinking about that. And again, if I didn't tell you how to amputate it, you can do whichever one you would like. All right. So here we have one more, I believe, if I'm remembering correctly. So, oh, I just did this, didn't I? Okay, it's okay. So, you know what? I'm gonna change this, that we're getting another practice one. My bad. Let's change this to x minus 3 squared plus 2. And I'm going to restrict the domain to negative infinity to 3. So we're going to graph this. So I probably shouldn't start with that. What's my vertex is 3, 2. And if I plug in 3, I get an output of 2. If I plugged in 4, I would get an output of 3. If I plug in 2, I'm going to get an output of 3. If I plugged in 5, I get an output of 6. And if I plug in 1, I get an output of 6 as well, right? So I've got this beautiful parabola. Oh, no, I don't. Guys, I messed up. I shouldn't have graphed the whole thing. Can I erase? Or is it going to make me erase the entire screen? I'm embarrassed. Shh, darn. What should I do? I'm going to just use a new color. Can I use white? You think I can do that? Well, which side should I have graphed? I shouldn't have ever gone past 3, right? So I need to get rid of all of this right here. It's kind of like I'm erasing. It's like disappearing, kind of. It's like a really bad eraser. That's not a great eraser. Can I make the pen, like, better? No, I can't. Oh, is it getting better? I don't know. You guys don't want to watch me do this. Like, if you're even still watching, if you're like, wow, this is ridiculous. It's not bad. Okay, so I should have just grabbed, it's kind of like when you erase on a piece of paper and it doesn't erase well. I think I already said that. I'm losing it, guys. Okay, so is the original one-to-one? Because of this restricted domain, yes, it is, right? The domain which was given to you is negative infinity to 3, and the range is, I mean, that's not impacted, right? That's going to be from 2 to infinity. Is the inverse a function? Yes, because it's 1 to 1. If you're answering yes to this, you better be answering yes to this, right? These are essentially asking you the same question. So when I graph the inverse, instead of 3, 2, I'm going to have 2. This is going to be fun. 1, 2, 3. Instead of 1, 6, I'm going to have 6, 1. Instead of, I'm going to have a point here also. Look, they like overlap. How cool does that look? Right, and it reflects over this line. So the domain is just going to follow, right? The domain's then going to be from 2 to infinity, and we can confirm that. Look, 2 to infinity. The range is going to be from negative infinity down here, lowest to highest. So you better be careful that it's going from the smallest to the biggest, right? Or you can say y is less than or equal to 3. So when we're writing this equation, if you're going to solve this, so let's say I'm going to do x, y minus 3 squared plus 2. I'll go ahead and subtract 2, y minus 3 squared, and I take the square root. Just as I said before, this is plus or minus. However, we restricted the domain, right? We only care about part of it. We care about the part that is less than 3. We care about the negative part, right? We want the negative part, so we need to add that in. So then I'm going to have y minus 3 equals the negative square root of x minus 2, and then go ahead and add 3. So I can and I should use inverse notation here. Function inverse notation. Negative square root of x minus 2 plus 3. All right, and that is this graph. Amazing. Okay, so I know this is a little tricky, but feel free to make up more problems. Like, see how I just quickly changed that? Make yourself some more problems and practice with them, right? Like, try some different ones out and see if you've got it. See if you get, like, how to switch it and how to think about it. And can you write your own restricted domain, right? You guys got this. Like, you can make up your own problems for practice. So in this lesson, we talked about how to use, and we really focused in on one of those 5 fun facts and how we can modify an equation that is not 1 to 1 and make it be 1 to 1 so that we can figure out the inverse, right? So we talked about amputations of a function, right? Or domain restrictions, and that we have control of the domain. We don't have control of the range, that's the output, but we control the domain. So if we want to restrict a domain, we can restrict a domain. So I encourage you to make up some of your own practice problems and try them out. And if you need to go back and rewatch any of this, feel free to do so. So thank you guys so much for watching.